Hello everyone, welcome to our channel Higher Mathematics. In this video lecture, I am going to discuss next PYQ of Linear Algebra asked in CSIRNet December 2023. So our question is, for A belongs to R, let A of A is equals to this matrix 2 minus 1 0 minus 1 2 minus 1 0 minus 1 A. So which of the following statement is true? Here we have to see the positive definite of this matrix, that is for which value of A this matrix is positive definite. So this is a question based on the quadratic form. We know in a quadratic form, what is the quadratic form? X A X transpose AX. This is a quadratic form, and if the quadratic form is positive definite, then this is equal greater than 0 for every x, right? But here there is a shortcut trick by which we can solve this. If we have to see this matrix as positive definite or not, we have to see the minus, as this matrix A is what? 2 minus 1 0 minus 1 2 minus 1 0 minus 1 and A. So for positive definite we see the minor. What is the first minor? That is 2, that is greater than 0. Minor should be greater than 0, then this matrix should be positive definite. The first minor is what? This is 2. What is the second minor? This. If we have to find the determinant of this minor, what this? 4 minus 1, that is 3, that is also greater than 0. First minor, we have to see the minor. The first minor is 2, that is greater than 0. Second minor is 2 minus 1, 2. If we have to find a determinant of this, this is also greater than 0. What is the determinant of this? 4 minus 1, that is 3, that is greater than 0. So for the largest minor, we have to find a determinant of this matrix only. So what is the determinant of this matrix? 2 of 2A minus of 1 plus minus 1. This is what? 0 minus and minus plus A. So what we get? 4A minus 2 and minus of A, which is equals to what? 3A minus 2. And for positive definite, this determinant should be greater than 0. So A is greater than 2 by 3. For positive definite, but for a positive if the determinant is positive, then eigenvalue should be positive, because we have see the two minors are already positive. So here, if the determinant is greater than 0, then value of A should be greater than 2 by 3, right? Now we will check the option. Here, greater than 2 by 3 is what? A belongs to what? A belongs to 2 by 3 to infinity. That any value between this is give the matrix positive definite. So option D, what? A is a positive definite only for finitely many value of A. We know that it is an interval, and here it contains infinitely many value. So this option is incorrect. We can get infinite value of A for which this is positive definite. Now for option C, CA is a positive definite for A greater than or equals to minus 2. So if we take minus 1, then it satisfies? No, because A should be greater than 2 by 3. And if we take A greater than minus 2, it can be minus 1, it can be 0. So it is not lie in this interval. So for positive definite, A should be lie in this interval. So this option is incorrect. Here, option A is positive definite for all A greater than less than 3. If we take less than 3, so here less than 3, it can be 2 lie here. But if we take 0 don't lie here. So we cannot say A greater than less than 0, it means what? Minus infinity to 3. But our interval is this. So this option is also incorrect. What is B option? A is positive definite for A greater than 3. A greater than 3 is lie in this interval, right? So this option is correct. So this is a recent question of CSIRNet based on that quadratic form. We have to use a trick for solving this question. This is the solution of this question. If you like this video, hit the like button, and for more such video, you can subscribe my channel. Thank you for watching.